In this first example, we want to find the vertex, axis of symmetry, and then the x and y intercepts for our quadratic function f of x equals x squared minus 4x plus 3. This is from the previous page. We can tell that this quadratic function is in general form. Therefore, we will find the vertex by identifying b and a, and then we'll find the axis of symmetry much in the same way. We already know how to find intercepts by letting the opposite variable be 0, so we'll do a review of that in this video as well for this example. And then lastly, we'll put it all together on Desmos just to show kind of what it looks like graphically as well. Okay, so let's first identify what A, B, and C are, because we're going to need that, at least A and B. So our A value is 1, our B value is -4, and then our C value is 3. So I'm just going to write out what A and B are because we just need those. Okay, so that's important information in order to find the vertex. In order to find the vertex, we take, the vertex is a coordinate point, right? So in order to find the vertex, we take the opposite of b over 2a. So our vertex is going to be, the x-coordinate's going to be the opposite of b, so +4, over 2 times a. So this is 4 divided by 2, which is 2. So the x-coordinate of our vertex is 2. And I realize here I should have another parentheses there. Okay. All right, so we found the x-coordinate of our vertex. Now we need to find the y-coordinate. And this looks more complex than it really needs to be. All this says is you have a function and you have what the x-coordinate is. Literally plug it in, right? So we just found that this piece is 2. So in order to find the y-coordinate, we plug in 2 into our function. So our y-coordinate of our vertex is f of 2. It's what the y-coordinate is when x is 2. So f of 2 is 2 squared minus 4 times 2 plus 3, right? Because this is our function there. Okay, so when we keep plugging away to see what we get, we'll get -4 plus 3, which is -1. So the vertex is the coordinate point 2, -1. All right, the next thing we want to find is the axis of symmetry. The axis of symmetry is pretty easy. It is the vertical line that passes through the vertex. So the reason I wrote it like this is because it's x equals whatever the x-coordinate of the vertex was. Well, we already found that -b over 2a is 2. So the axis of symmetry is just that vertical line, x equals 2. So we have used the formula to find the vertex and the axis of symmetry for this quadratic function. The next thing that we're going to look at are the intercepts. All right, to find the x-intercept or intercepts, we let y be 0. So we're going to replace y, or f of x, with a big fat 0. So we're going to have 0 equals x squared minus 4x plus 3. Now, this quadratic is equal to 0, so we want to see if it's factorable or not. Are there two numbers that multiply to 3 that add to -4? Yes. Those numbers are -3 and -1. Then we have to set each factor equal to 0 and solve. So we'll say x minus 3 equals 0 and x minus 1 equals 0, and that gives us 3 and 1 as our x-intercepts. So our x-intercepts are 1 and 3. Lastly, we'll find the y-intercept. And we do that by letting x be 0. So if we let x be 0, we'll have f of x equals 0 squared minus 4 times 0 plus 3. and that is 3. So our y-intercept is 3. All right, I brought up the graph of this function that we just analyzed. The vertex of our quadratic function is the coordinate point 2, -1. That's what we found algebraically. If we go to 2, -1, that is the vertex. This parabola opens upward, so the vertex is our most minimum point. It's a turning point down here. The axis of symmetry is the vertical line that passes through the vertex, and that is that line x equals 2. We found our x-intercepts through factoring. We found that the x-intercepts are 1 and 3. Let's make sure that's where our quadratic function hits the x-axis. It does. And our y-intercept is 3. It is. So feel free to use Desmos to double check everything that you find. In this example, we're actually going to be using the exact same function, but first we want to write it in vertex form and then find all of those same things. So they'll be the exact same solutions as in the first example, but we're going to find them in vertex form. We'll also practice getting into vertex form by completing the square. So if you have not watched part 2, general and vertex forms, please do so. All right, so we are going to first get it into vertex form by completing the square, leaving a spot on each side. We do have a positive 1a value here, so we don't have to do anything to change that. So we have x squared minus 4x, leave the space to complete the square, and then we have our plus 3. The number that goes here, and then also here, is half of our b value, so half of -4, which is -2, and then we square it. So squaring -2 gives us positive 4. So we're adding 4 to that side, so we have to add 4 to that side. So we have on this side f of x plus 4 equals, and we again have created a perfect square trinomial. This can be factored down into x minus 2 times x minus 2 or x minus 2 quantity squared. That's why it's a perfect square trinomial. And then plus 3. We want f of x by itself, so I'm going to subtract 4 from both sides. When I subtract 4, I'll have a -1 at the end. All right, so this is our function in vertex form. So this is vertex form. It's called vertex form because it very easily gives us our vertex. All right, in order to find the vertex in vertex form, this is what we had written down on the first page here, the introduction to how to find the vertex in axis of symmetry in vertex form. So the vertex is hk, and the axis of symmetry is x equals h. I'm going to write out what vertex form looks like underneath this. It is f of, and again, this is all written down from the beginning. So this is what vertex form looks like. And so we can see that it's in this form. A is 1. Here's our x. This really could be a plus or a minus, but the h is whatever comes after a minus sign. And then out here we have squared, right? And then out here we have plus k. So this is really plus a -1. So while here h would be 2, because it's x minus whatever h is, and this is x minus 2, h is 2. But since this is plus k, we have a -1 here. What did we add, right? What's k? It is -1. All right, so let's figure out what our vertex is. Our vertex is hk, h is 2, and k is -1. Then our axis of symmetry is the vertical line passing through the vertex, so it's x equals 2. I already know that the x-coordinate of my vertex is 2, so easily it's x equals 2, or we can see it's x equals h by definition. All right, the last thing that we need to find are the intercepts. We already know what they're going to be, but we're going to find them using the vertex form instead of what we did earlier in the general form. Okay, to find our x-intercepts, we're going to let y be 0. So I'm going to have 0 equals x minus 2 quantity squared minus 1. When we solve this, I'm going to add 1 to both sides. So I'll have 1 equals x minus 2 quantity squared. And here's where it gets a little fun. We need to undo that squared. So I'm going to do a big square root on both sides. When we do that, the square root of 1 is both positive and negative 1. We are solving an equation here. So we need to account for positive and negative 1. And on this side, we took the square root of something squared, so we're just left with x minus 2. This actually leaves us 2 equations to be solved. One of the equations we deal with 1, and in one of the equations we deal with negative 1. So I'm going to make 2 little arrows here. So we have 1 equals x minus 2. And we have negative 1 equals x minus 2. We know that a parabola at most is going to have 2 x-intercepts, so this is where they're coming from. Here we'll add 2 to both sides and we'll get x is 3. Here we'll add 2 to both sides and get x equals 1. So we know that those are our x-intercepts. We know that because we've already found them. In order to find our y-intercepts, we let x be 0. So we'll have, instead of writing f of x, I'm just going to write y, and we're going to let x be 0. So we'll have 0 minus 2 quantity squared minus 1. So we'll have negative 2 squared minus 1. That gives us 4 minus 1 gives us 3. So our y-intercept is 3. I'm not going to get into this graph as much. It's the exact same graph we saw before, only this time I put it in its corresponding vertex form. So it's the same graph as it was in general form.